Because what you guys just did was you just figured out a rule on your own. So turn to 4-6. I'm going to give you the section title, but you'll get it again on Monday when we finish these notes. But who can tell me in their own words here, why was it that the pink one didn't work and the other two did?
Because the sides were shorter.
1 second, Noah.
Too short.
Yeah, these are too short. When you try to connect it, there's a gap right there. But since these two were longer than this one, it could work. And these two were longer than this one, it could work. So look at your notes. Go down to about the middle of the page where it says that it's the triangle inequality theorem. Fill in the blank right there.
Wait, Mr. Ask, I'm confused where we are.
4-6. And now look down about in the middle of the page. Find this rule right here. Okay, fill in the blank.
Found it.
We're on 4-6. We'll worry about that Monday. We're only just going to do this part. Okay, triangle inequality. Down to the middle of the page. Triangle inequality theorem. The sum of the lengths of any two sides of a triangle is what? Then the third side. Greater. See? You guys figured that out all on your own. Okay, that's what you did with the straws. You figured out, you made up a rule that that is true. So for a triangle to exist, you need two of the sides to be bigger than the third side. So in one case, you need side AC plus AB. If you added these two sides together, they would have to be bigger than what side? If you added AC and AB together, CB, bigger than CB. Okay, any two sides you add together have to be able to overlap or be bigger than the third side. Otherwise, they couldn't all connect. That has to be true for all of them. AB plus CB, these two, AB plus BC, would have to add it to be greater than AC or CA, either way. And the last one that has to be true is that AC plus CB, this one plus this one, when you add them together, they would have to be bigger than AB. Okay? Now, that's true, but it's going to be a pain to try to test all three of those. So I'm going to save you a lot of time by giving you this. Write this down. In order to prove this rule, that's a little star. In order to prove this rule, you only have to try two sides. You test the two shorter sides. Okay, so you don't have to test all of the different possibilities, you just find the two shortest ones. If it is bigger than the third side, then you're good. It's gonna make a triangle. Let's look at the examples down at the bottom, and you can help me with it. I do have it printed out, but right now I'm using the phone, so I'll show it to you at the end. All right, test the two shorter sides. Anyone still writing?
No.
So look at this one. Can a triangle have these three sides? Imagine these are the numbers of the pink or the yellow straws or whatever. Okay, we have to see if it's possible to create this triangle. So now we have numbers. What I do is I find the biggest side, and then I test the two smaller sides. What's the biggest side here?
25. The biggest side?
33.
Oh, it's
So the two other sides have to be greater than 33. Does that make sense?
Like,
Are you ready for the test?
No, just because it's bigger.
I took another L.
Yeah, that one.
So 22 plus 25, what does that make?
Was 47.
All right. If the two sides make 47, is that big enough? Is that greater than the third side?
Oh, yes.
Yeah, so your answer is yep, that can make a triangle.
Scooby.
Okay. If the two smaller sides is bigger together than the third side, then you can have a triangle there. Letter B, what's the biggest side?
11.
Add the two smaller sides together. 3 and 7 make 10. Could a triangle be made out of these? That's correct. Very good. So no. It would be like the pink one, where the two sides are too small. 3 and 7 would make 10, but this one's 11. It wouldn't connect. It's too small. Okay, you see the idea there?
Yeah.
Alright, one last thing you need to know is a question like this.
I don't even know.
1 second. It's a different kind of question.
No, I
The
just
two
know.
sides, let me go through. The two sides of a triangle are 11 and 12. So please copy that down. No, I'm good. Let's go through this thought process. Okay? This is 11 and this one's 12. The third side is unknown, so let's call it X. So this is a different kind of a question. It's not asking you, can a triangle exist? It's asking you what values of X could make the triangle exist. Okay, and the question is to find the range. When someone asks you for a range, you don't just give them a number, right? What do you give them? 2 numbers. You have to give them a low to a high. Huh? Yes, an inequality, that's right. If someone asks you for what's the range of ages in this class? I don't say 15, I say like 14 through 17 or whatever. I give a low value and a high value, okay?
There you go.
So, focus here, please. This is super important, but it's really easy. It's extremely important, though, because I've seen it on the test. All right, to find a range, you need a low value, and you need a high value. And then you're going to put X in the middle with the inequalities, like Francisco said, but since we're going low to high, would I use less than or would I use greater than? But I'm starting low and going up to high. So it's got to be less than. This one's less than this, and this one's less than this. The high end is open to the greater than side. Okay, that's it. Now this is the really easy part that you have to hear me say. Once you hear me say it, you're going to be able to do all these kinds of problems. To find the low end, all you have to do is subtract.
So it's 1.
Mm-hmm.
No way.
Yeah.
No way.
And to find the high end, what would you do?
Add.
Add.
No.
That's right. And you put X in the middle. So you don't have to write this out every time, but write it in your notes so you'll have it. I would subtract 12 minus 11. Yes. And I usually don't write that out and get until the end. 12 minus 11 to subtract is 1. For the high end, you add 12 plus 11. So what would that one be?
23.
And your X would be in the middle. Now you can't use 1. It doesn't say less than or equal to. It says less. So what's the first number you could try to use?
1.
1 is less than.
X.
Yeah, so what's one of the first values we could try?
X.
2.
2.
Oh, it can't be.
Can't be 1 because it doesn't have the or equal to sign under it.
Oh, yes.
Okay?
Yes.
So it could be 2, 3, 4, 5, 6. It could be all the way up to what number?
22.
22. Okay, so you would almost have had it, but I wanted to go through this whole process. I still want to go through the whole process. Okay, turn the page. Turn the page. That's
So the answer would. So the
That's
answer.
the answer. That's the range. It has to be between 1 and 23.
Oh, so you don't name a specific number then?
No, because there's other possibilities.
Will it ever ask for a specific number?
I don't want to say no, but commonly it's this. Okay. On the back side, I just want to make sure you see the difference between the questions. So we're going to be doing number 1 through 9. If you don't finish it in class today, you should be able to. If you don't, then that's your homework to finish number 1 through 9. The second part of your homework is to start looking and seeing math around you wherever you go in the world. Okay.
Oh, we did this last year.
Today?
Grab your phone and like, yeah, we tried it a couple times. Take your phone and just snap a little picture, okay?